So cybernetics history, first order cybernetics arose from and grew with a desire to understand control processes and iterative and recursive behavior in engineering, physics, and biological systems, and mathematical applications. Second order cybernetics generalized in particular, noting that in social systems, the observer, the subject, and the process interrelate. And I think what Professor Medvedeva was saying, that is in third order cybernetics, this relates to an entire social or socio-technical system, and we have to consider the entire system as well. And I wish we had seen this presentation before we wrote ours. Okay, so as an introduction, we're going to look at the works of, we were reading the works of 20th century philosopher, theologian, and commentator on science and social science, Bernard Lonergan, and we find echoes and even anticipation of major themes of second order cybernetics. We did this in the context of a class on logic, the limits to knowledge, and its interaction with philosophy, religion, and just about everything else under the sun. Okay. To explore these connections and parallels the difference with second order cybernetics and Lonergan's approach to theology, epistemology, ontology, teleology, mathematics, and logic. Okay. And there is the picture I like to think of. Lonergan is motivated by philosophy and theology, something that is very equivalent to second order cybernetics and formal sciences and the interrelation among the three. Okay. Lonergan's ideas are an emphasis on the process of knowledge and cognition, a re-examination of Thomistic experience, understanding, judgment cycle, the view as a view of human knowing, and the insistence on understanding the role of the observer as a key to valid knowledge, which gets us right back. An important influence was the English empirical tradition engaged by John Henry Newman, who was about to be canonized. Newman assisted Whately in his popular work Elements of Logic, which was a major logic text in the 19th century. Whately was himself an archbishop in the Church of Ireland, and the themes have been that the individual is an understander and judger, and this is central to objectivity, not just to subjectivity, but to objectivity. Newman and Lonergan arrived at their stand on knowing and objectivity by way of a long pedagogical process of what Lonergan calls self-appropriation, and this pedagogical process is also central to Newman's grammar of assent. There's a call for method accepted and employed in philosophy and theology as compared to the scientific method on the one hand and the structures of mathematics on the other, resulting in his generalized empirical method. A key is the need for reflection, that is insight in philosophy, science, mathematics, social science, and I suppose everything else. And an integration of the social, natural, and formal sciences into his work, sometimes as a topic or perspective, sometimes as a tool, and sometimes by analogy. So the generalized empirical method asks 4 questions. Cognitional theory, what do I do when I know? What happens in our judgments of fact and value? Why is doing that knowing? How can we call it objective? How can we call it knowledge? What do I do when I do it? Understand the process, understand the structures of knowledge and value. And what, therefore, should we do? Lays out a framework for collaboration, and in light of what Celia and Philip were talking about, for decision based on the answers to the first 3 questions. So our outline is to review development and major ideas in first and second, development sources and major ideas in first and second order cybernetics. Consider Lonergan. Look at interactions and implications for knowledge, cognition, learning, and insight, and in particular for formulation and examination of research models and approaches, and consider views from the perspectives of natural and biological sciences, the formal sciences, which is to say mathematics, theoretical computer science, logic, and some aspects of data science, the social sciences, including economics, and philosophy and theology. So the whole boat. If he had thought about it, he probably would have thrown the arts in as well. Okay, so codify the overlaps, the contrasts, and the interactions, present a perspective, integrating his views with cybernetics, consider differences and conflicts, consider some broadly applicable and a few more narrowly applicable lessons, and present our conclusions and select paths for using and further exploring this connection. Okay, so first order cybernetics begins, as Professor Medvedeva said, with Norbert Werner used cybernetics in 1948 book on control and communication in the animal and in the machine. Cybernetics comes from a Greek kybernetes, meaning steersman, governor, pilot, or rudder, and I understand from Professor Umpleby the preferred term now is governor. But you notice it refers both to the decision maker and to the mechanism. Okay, this established foundations for control theory, analog computing, artificial intelligence, neuroscience, communication theory, and probably a lot of other things we left out. Okay, also H. Ross Ashby, so notice that was mathematics and engineering. Ashby was motivated by the concept of the homeostat, developed the law of requisite variety, the principle of self-organization, and the principle of regulatory models. Followed, so psychiatry, but theory of the mind from a technical perspective largely. Then mathematics, physicist, computer scientist, John von Neumann, who made contribution to cybernetics when he developed the cellular automata, self-organizing systems of behavior in space or on the plane. Okay, now we get to second order cybernetics, and we still have physics and engineering, but we start getting philosophy. Okay. Von Foerster established the biological computer laboratory. We're getting the biological sciences coming in. The focus was on self-organizing systems, bionics, which is the application of biological methods in natural systems to the study and design of engineering, bio-inspired computing, so using biology largely as analogies. We then had J. Wright Forrester. I'm lucky I keep the two names straight. Computer engineer and management scientist, so management is coming in. Second order cybernetics with an emphasis on modeling and simulation of complex systems. Founded the Systems Dynamic Lab. Nonlinear behavior, complex systems, taking, examples from stocks, flows, feedback loops, table functions, time delays, analyzing industrial business cycles, management. Bertalanffy, biologist, general systems theory, universal theory of systems with broad applications, emphasizing holism over reductionism, organism over mechanism. And someone, Stuart Umpleby, who studied cybernetics with von Foerster and Ashby, professor of management, expertise in system dynamics, philosophy of science, organizational behavior, and past president of the American Society for Cybernetics. And I wonder if anybody recognizes that fellow up there with Umpleby. It's Okay, and I will turn Bernard Lonergan.
Thank you. So as many of you know, if you attended...
Oh, microphone. Yes. Sorry, I thought I was being given this as my award.
If you've attended one of my earlier presentations, Bernard Lonergan was a Canadian Jesuit who did significant work in philosophy and theology. And later in life, he expanded his interest into other disciplines, particularly the social sciences and economics, macroeconomic theory. In Lonergan's most famous book, which is entitled Insight, he advances the idea that the very common and basic supervening act of understanding is operative throughout and is critical for all cognitional activity. And Lonergan views learning as a structured interweaving of experience, understanding, and judging. And when you've gone through those 3 steps, then you're at a point where you can make a responsible and reasonable decision. What Dr. Marlowe and I and some of our collaborators noticed at Seton Hall was that a lot of the elements of Lonergan's cognitional theory aligned closely with elements of second-order cybernetics, particularly the fundamentally reflective and systematic nature of it. And while Insight is the linchpin of Lonergan's system, it is structured by a kind of feedback loop that is formed through the 3 steps of experiencing, understanding, and judging. This experience leads to other insights, and then further understanding and further judgments, and then ultimately further decisions. So the loop is inseparable from the knower who experiences, understands, and judges. So right away, the connections should be jumping out with second-order cybernetic theory. It's important to point out that Lonergan's cognitional theory is not only to be understood as systematic, but also as seeking systematicity, seeking understanding on a systematic level, yet within that system and thus interacting with it, not separate. And so Lonergan sees himself as bringing this much needed systematicity to a variety of disciplines in the 20th century, most especially philosophy and theology. He notices that this approach has been successful in mathematics and in physics, and so he's trying to identify those positive aspects and, as a methodologist, see how they can translate into other fields. Now, in the course of this research, we did discover that there are moments of departure between Lonergan and most cyberneticists. One such moment concerns the turn to the second order. For Lonergan, the cognitional structure presumes the knower is situated within being, and this kind of Aristotelian empiricism does not hope or suppose that it would be better to inquire into being from the outside. Second-order cybernetics may allow the knower to start outside, although observation brings the knower inside as an interactor. And a second point of departure could be in the notion or conception of structure. We notice that within cybernetics, the structure of a system has to be understood as abstracting something from the object of investigation. And this abstraction can come without an evaluative judgment about the relative significance of what is abstracted out, or with a judgment that deems that which has been abstracted as irrelevant or unimportant. But for Lonergan, structure is decidedly more ontologically pervasive. For Lonergan, insofar as something is, it's intelligible, and if it's intelligible, it's structured. So in Lonergan's approach, systematicity permeates all of being, and the knower's attention to it is not a matter of abstraction, but rather an admission of the isomorphism between being and our unrestricted desire to know. It's an important footnote, in a sense, to point out that intelligible and structured does not mean fully knowable. Lonergan was certainly aware of the work of Gödel. Keynote presenters here at this conference over the past years have touched on many of the same themes. And many more.
We apologize if we misstated anybody's position.
Yeah. So it might be beneficial to consider scientific disciplines from both perspectives, from Lonergan's approach as well as from a second-order cybernetics approach. We can think about science as an interaction among nature, the professional and academic community, and the individual scientist. Science evolves through the understanding and judgment of individual scientists. This leads to modeling, theory formation, and interpretation, and interacting both with experiment and with the community. The role of these three, and in particular the relevant domains and attributes of nature and the balance among the three, change as one traverses the spectrum from the social sciences and economics to the biological sciences and finally to the natural sciences and formal sciences. The dependence of the conclusions of the social sciences not only on interaction with the subjects, but also with the observer scientist is well accepted in the academic community. But both second-order cybernetics and Lonergan view observer interaction as key in the biological and natural sciences as well. Most second-order cyberneticists don't devote much attention to the formal sciences, nor give them a privileged role. And Lonergan, in contrast, is very different. He looks to logic and mathematics. One reason for that special attention is to draw out the nature and significance of the empirical method. What is empirical about the GEM, the generalized empirical method, is not that it takes for granted a material existence that gives us rise to our ideas about the external world. This view may be forcefully rejected by many formal sciences or scientists. Lonergan takes as a given the data of consciousness, the content of our experiences, our judgments, our insights. These data are within the knower and as such are present in the cognition of all inquiry. As such, the formal sciences do not occupy a special epistemological position, but serve a useful epistemological role. The most privileged science for Lonergan is metaphysics, because questions of meaning in general, and in particular a technique for determining and integrating meaning, require metaphysical equivalence. In the GEM, a person engages in a discursive process between apprehension, insight, and judgment. Lonergan's notion of insight is the crucial link between simply perceiving data and true understanding. This is a huge point for Lonergan, that we know the difference between perception and understanding. It's one thing to notice something, and it's completely different to genuinely understand it. And the GEM also includes the important processes of attention, imagination, and memory. And this should ultimately lead to decision and action. Clearly, parallel to the cybernetic notions of observation, feedback, communication, and control, Lonergan doesn't treat human cognition as a static object that we just observe. He acknowledges the dynamicity of the human mind and the importance of self-appropriation. Concern is not knowledge of an abstract self. It must be a self-appropriation. He hopes to lead people to an experience of one's own self-consciousness taking possession of itself. An important aspect of cybernetics is the science of observing and describing dynamics, as well as interacting in engineering and biological processes. Lonergan interestingly engages in an analogous quest for the human intellect in his development of the GEM. So both Lonergan and second-order cybernetics would certainly agree that science always involves the scientist. But there are differences. Certainly as a priest and professor of dogmatic theology, Lonergan's concern was mostly in the theological domain. Many cyberneticists have of course, other concerns closer to fields like artificial intelligence, autonomous craft, whether submarines, spacecraft, bionics, biological inspired systems, or cyborgs. Lonergan, with metaphysics and epistemology, always acknowledges human beings as reasoning agents and the role of reasoning. And that reason is, of course, open to the full breadth of human experience. Lonergan also has, as noted, a very different view of both nature and the role of logic and mathematics. For Lonergan, these are, in addition to structures for formal deduction, models of conceptual reasoning and the epitome of the role of intuition. On the other hand, second-order cybernetics, on the whole, are less interested in the role or process of mathematical inquiry. Early second-order cyberneticists, largely following Wiener, tend to see mathematics primarily as an adjunct to science and engineering, a supporting tool, with a focus on the second wave on the biological and social sciences, and on design as a cognitive process. Mathematics is part of a toolkit, a supporting infrastructure. And I'll pass the baton to Dr. Marlowe.
Okay, not very long now, but we'll do our best. Okay. Let me try to do this in a way that doesn't kill the sound. That's not a good one. Okay. All right. So there are strong similarities, which we've gone through. Okay. One can even possibly view Lonergan, because he certainly was a contemporary, as one of the founders, though perhaps a lot less well known and perhaps having only indirect influence. But it provides useful insights on its development and on its theories. Its continued value for the philosophy of science, broadly understood, and of cognition, and for the study of science. There are strong similarities, and that's where I was. Okay. On the other hand, there are differences. Priority given to epistemology and metaphysics. Questions of meaning in general, particularly in terms of relation to the divine or to the absolute. A technique for determining, a specific, though generic, technique for determining and integrating meaning for its own sake and to deal with important questions. Okay, and our open issues. Further study is needed to determine the exact extent to which Lonergan was aware of second-order cybernetics and vice versa. In addition, we'd like to compare the view and treatment of the formal sciences more fully. We invite further discussion with second-order cybernetics practitioners and theoreticians to determine their awareness and reaction to this work, and if they don't know it, to ask for their reaction in the future. We hope to contact Lonergan scholars to pursue the opposite direction, and we would like to pursue Lonergan's reference in the Method of Theology, a later work, to functional specialization and the influence of Carl Ludwig von Bertalanffy. I always get that name wrong. Okay, so some questions. What could philosophy and theology learn from second order and now third order cybernetics? What could second order cybernetics learn from theology and philosophy, and in particular the approach of Lonergan and even Barber, who was talked about in Father's earlier plenary? And first issue, consider philosophy more explicitly and make Jeremy Horn happy. Consider Lonergan's approach to insight, pay more attention to the formal sciences. I think this is one of the more surprising messages, actually. For the reasoning processes as a computational process, as analogies, and in the precise formulation of limits to knowledge, which I've talked about before. And thank you all